In today's video, we will look at parallel lines. So let me draw two lines here. I'm going to try my best to make them as straight as possible. So we have one line here and I'm going to call it L1, and I'll draw another line and let's call it L2. So two lines are parallel to each other if they meet three separate conditions. So the first one is that both the lines need to be on the same plane. A plane is like a flat surface. So in this case, the screen is a plane. If you're writing in your notebook and making notes, your paper or the page in your notebook is like a plane, or the floor or the wall is a plane, so any flat surface. So these two lines are in the same plane because they are on the screen. The second condition is that they should never intersect. This means that even if they keep going on forever and ever and ever and you extend them, even then they should never intersect with each other. So let's take this example. We have these two lines, and these two lines don't really intersect with each other right now. But let's make sure we draw them as lines. But what if we were to extend these lines? So if I were to extend this like this, and if I were to extend this like this, you will see that they're bound to intersect each other at some point. And the third is kind of a trivial condition, is that they should not be the same line. In this case, they're obviously not the same line, but let's take this example. Suppose we had this line here, and we had these points A, B, and C. So we have a line AB, and we have a line AC, and these two are not parallel to each other because they're essentially the same line. So in this case, we have L1 and L2, they are on the same plane, they won't intersect even if they keep going on forever, and they are separate lines. Now the way you show that lines are parallel to each other, on the figure the way you would show it is with this symbol like this. You could have one arrow, or you could have two arrows, like you could have two arrows like this, and that means these two lines are parallel to each other. You could have one arrow, and that also means that they are parallel to each other. And the way you would write it is like this: line 1 is parallel to line 2. Now there is a more formal definition of parallel lines, and it was put forward by Euclid, who was this major mathematician who did a lot of work in geometry. And this is what he put forward. It's called Euclid's, so let's write that down, Euclid's fifth postulate. A postulate is like something that's given to you. It's an assumption that you make. It's not something that you have to prove. Here is what Euclid says in his fifth postulate, and I'm translating it for ourselves in a simpler language. So here is what he says. If you have two lines, let's call them L1 and L2. So if you have two lines, L1 and L2, and they're cut across by another line. So this line that cuts across is called transversal. And as you learn about parallel lines, you will see a lot about transversal. Now here is what Euclid says. He says that if these two angles add up to 180, which means that they are supplementary, then L1 and L2 must be parallel. And the way you write it is, if the same side, because literally they are on the same side of the transversal. So same side interior angles, again interior because they are not here or here, they are on the inside. So if the same side interior angles add up to 180 degrees, then the two lines must be parallel. So let's look at two examples. So let's draw two lines here. And it's cut across by a transversal like this. And say this is 70 degrees and this is 110 degrees. Now if we call these lines L1 and L2, then these two lines are parallel to each other, and we would write that as L1 is parallel to L2. Now let's draw another pair of lines. So we have this line here, and let's call it L3, and we have this line here, and let's call it L4. Now if we have a transversal that goes about like this, and we are given that this angle is 85 degrees and this angle is say 110 degrees. Now these two lines L3 and L4 are not parallel to each other. So L3 is not parallel to L4, since the same side interior angles do not add up to 180 degrees. They in fact add up to 195 degrees. So in the next video we will look at how to use Euclid's fifth postulate along with our knowledge of supplementary and vertical angles to find unknown angles given parallel lines.